Hello and welcome to the World of NDE 4.0. My name is Johannes Flana and today is a great day because today we will finally get to a topic which I think the NDT community has to face. Today we will start with the discussion about NDT value perception. You might ask, where is that topic coming from? Now, about a year ago, I did a survey on social media and asking, what have you heard on negative things about NDT? And actually, I got a lot of answers. And therefore, I started grouping those answers. And at the end, there was one group, which was by far the biggest group of answers. And they all were connected to, NDT value perception. Like those. Like the ones here you can see here. NDT is non-value added. NDT is a production break. NDT is an unnecessary cost vector. And many more, not just the two additional ones I have here on this slide. Now what we did is we put all of those comments into a paper. You can see the link to that paper right here. And we started to analyze them, to use a design thinking perspective on all of them. I think it became a really good paper. Now, for me, this was quite a surprise, because I guess as most NDT people, I thought NDT has actually a very high value. That people should be glad that we existed, or that we did the inspection, that we looked for imperfections in the material to sort out the ones which could break during the lifetime. Just like a radiologist who helps you to find out before it's too late. But somehow this is not really the situation which those comments are showing. It seems like some customers have a different opinion. So I started thinking, okay, where does this whole story come from? Now, if we think back to the beginning of industry, into the very first or very early industrial days, people really didn't know how to process raw materials. They didn't know how to design and manufacture components and systems. They didn't know really how to operate the various machines or mode of transportation. They didn't have any IT. They didn't even have a calculator back in those days. So they didn't have any experience. They had to learn. And if we think about how humans learn by making errors, or that's a big part of human learning. So they made errors during those early days. And this unfortunately resulted in some severe accidents. Now there is one example I want to show you, and that's from the power generation industry. So perhaps not really the very early days of industry, but it was also pretty early for power generation equipment and of that magnitude, of that size. Now that shaft I'm talking about was produced around 1970. And within the German NDT community, that accident is actually pretty well known. So what happened? The steam turbine rotor was produced around 1970. The power plant was operated for about 16 years without any major problems. And then it was taken down for some maintenance. They didn't really find any big issues. And on January 1st, they were slowly powering up that steam turbine so that actually people could have power on New Year's morning. And at about 6 o'clock in the morning, after about 4 minutes running on full speed, on full power, this happened. you can see this is the power plant. This is the casing of the steam turbine. Here on the right, we can see here this is the shaft of the steam turbine. And for size comparisons, this is 1 meter. 1 meter is about 3 feet. So you can imagine how big is that component and how heavy this is. And this is only half of it, because that huge shaft actually was splintered in multiple fragments. Some of them, did not only get through the housing of the steam turbine, but even left the building, flew about 2 kilometers, and landed in the field. We have to say, it was such a huge luck that, to my knowledge, nobody was hurt. And actually, to my knowledge, also no building or car or whatever outside of the power plant, that power plant is kind of destroyed, but nothing really severe happened. But what was the reason for this? We can actually see it. We can see here, in the middle of that huge forging, we can see here this flaw. And that flaw was already in the component at the day it was produced. And it had about the size of my arm, if you do the size comparison. So, that accident actually led to a lot of improvements within the design of such forgings. There is also a story to the NDT which was conducted on that component, and people learned a lot about that, but that's actually a story for a different video, and I will do that video pretty soon, so keep posted. Now, but what such accidents or what NDT actually helped to achieve? NDT identifies potential material imperfections. NDT is the method which massively increases machine reliability. And it is the job of NDT to prevent accidents like this from happening. NDT is also a central part of early day feedback loops, identifying potential design and production improvements. So if we think about the situation we had back in those early days, actually the business case for NDT was pretty straightforward. We had a high risk for such failures, for such catastrophic events. And therefore, the money for NDT was not the big issue. We had to make sure that those components were running safely, especially if you think about a nuclear power plant or an airplane or whatever. And the companies which produced those assets in the early days, actually, they differentiated to each other by technological performance benefits for the customers. So you were buying kind of the best product for your needs. But kind of that changed over time. The competition between the different companies offering those products became harder. The differences between the technological performance became more similar, which resulted in some price wars. And therefore, if we think about the situation we have currently, every company is looking for savings. And somehow, NDT is one of the fields they're really looking for savings. So let's have a little bit a deeper look into why this is happening. And we consider the traditional NDT business case, which we saw all up to the moment. This is really so that no accident happens. And what we do is we take the potential cost of an accident and the cost which is caused due to a loss and reputation if such an accident would happen, and we compare the cost of such an accident with the cost of NDT. And then we can say, okay, the cost of NDT is actually, we don't even have to speak about the cost of NDT because it's so much lower than any potential cost of an accident. Who sees this business case? About everybody in NDT, I guess. I would also say most people in quality assurance. There's a different side to that story, and that's business administrators. I call this business administrator NDT business case. But we have to say the number of accidents, it has dropped dramatically. And this is due to a better design. This is due to a better production, where we have to say it, NDT helped to get there. Due to NDT also sorting the good from the bad and just putting the good parts into the component, and therefore nothing actually happens. But still, the number of accidents has dropped. And it has dropped to a level that actually the time span between two accidents is actually in most cases lower than the employment span of the decision makers. Therefore, for them, it appears like NDT is a cost center. That NDT is something they have to do because it is written in some standard, but they don't want to do it because it just adds price to it, and they want to cut the price as far as possible. And this is kind of what business administrators, the sales guys, the controllers, some of the decision makers, the buyers, all of them, they see this business case for NDT, or the non-existing business case for NDT, I have to say. Now, this is kind of a black and white situation. And for me, both of them are not correct. For me, there is something in between, which I would call a realistic or a resiliency NDT business case. And it's kind of an insurance model. So, because if we look at the number of accidents, which has dropped, so perhaps we could consider that NDT is not as necessary anymore as it was before. But what happens over time if we know that we didn't have any accidents? We know that over time, it could be the quality of the products is fading. The quality of the components is fading, especially with that huge price pressure, with savings all the time. So there is a chance that the quality of the product is slipping. So we have a probability of quality drop. And if we multiply that by the cost of an accident, this is kind of the insurance model. It's a probabilistic model. And what it does, it keeps the resiliency of our products because it helps to monitor the quality of our products. So for me, NDT is key for product resiliency. And this is what actually our regulators and our insurance companies see. This is where they are working at. And this is why an insurance company will always put NDT and other quality assurance measures into their insurance policies, that we have to do it, that the companies have to do it to keep that resiliency at a high level. And who should be seeing that? I would think everybody. Both the NDT guys who currently think, oh, it's still cost of NDT, don't care about it because the potential risk is so high. And on the other side, the business guys who, don't want to do NDT at all. And I think both should be focusing on this realistic or Resiliency NDT business case. Now, I want to point out once more this probability of quality drop. Keep that in mind. I will come back to that point a little bit later. Now, I guess now you see with those different points of view, with on the one side, the NDT community who knows that NDT is a huge value center, and on the other side, that some of our customers, the asset owners, the asset owner operators, they know that NDT is just a cost center, and both are not correct. But this leads to the case that in some industries, the situation has developed to a point that NDT is becoming undesirable. That people already start trying to find a different name for NDT, calling it inspection or whatever, which doesn't do really any good. Because we have really to tackle the initial problem, and that's the value appreciation. But this explains some of the end user pains, perception, and remarks we captured in that Journal of NDE paper, and which are also captured in the Halloween special. And I will leave a link to that Halloween special right here. Now, I already said before this, monitor the quality for drop. So that we have to monitor, that NDT helps to actually monitor the quality, so that that if the quality starts dropping or fading, that we see it. Now, what do we need for that? So that we are capable of monitoring this. Now, if we think about our current situation is we inspect a component and we say the quality of that one is good or not good. It's kind of binary decision. And where we actually need to go is we need to be on a kind of linear scale instead of a binary decision. Not just saying good or no good, but how good is that one? And therefore, if we were all the time at a 95%, and we see that we are coming closer to a 90% of our quality, then we know there is some problem, and some problem we need to face somehow. And this is exactly where the cyber-physical loop I discussed in the last weeks and months on this channel is coming to its place. And we'll put a video to the playlist about the cyber-physical loops right here. And what the cyber-physical loop does, in a very short, we take the data from NDT. We take this quality measure we just talked about, and we put that into the IoT. Perhaps we even take more data to put it into IoT. We convert that with semantic interoperability to information, because NDT has only very little data, very little value, but information has a lot of value. And perhaps we combine the information from NDT with the information from other sources, put all of that in a digital twin, and create some knowledge out of that, perhaps showing us the quality trend. And then finally creating some action that if the quality drops, let's say below 90%, then we have to take some action. And perhaps the digital twin is even capable enough to actually do that processing in real time and even say, you should be correcting a certain thing. And this is NDE 4.0. Now, why am I not saying NDT 4.0, but NDE 4.0? For me, the key here, or if we look at the word NDT, it's non-destructive testing. And testing is something where we have as a final evaluation a good or no good decision. But what we are really interested in is data evaluation, to get more out of the NDT data, to get away from the binary decision go good or no good to a kind of linear scale. And this is why I think we need non-destructive evaluation. And this is why I like to call it NDE 4. Now, this is a first digital physical loop, or how I like to call it, a cyber-physical loop. But there are many more. Many more applications where NDE can help actually to achieve those cyber-physical loops. And on the next video, I will have a look on one of the value streams and look at a lot of possible cyber-physical loops we can actually achieve on that value stream. So thanks a lot for watching. If you have any comments, if you have any questions, feel free to leave them down here in the comment section. And next time, as I already told you, I will be talking about a very good, or a first value stream and the connected cyber-physical loops. As usual, you will find more information in the description. I hope you liked this video. I hope you subscribe to this channel. I hope I will see you soon. So thank you for watching. See you soon. Thank you and bye.